Welcome to DFINITY Global R&D meeting for January 2025. My name is Saša. I'm going to be the MC for today. So let's get going. We have a very interesting agenda today. The first comes contrast to the regular community demos that come at the end. Today, we're going to have a community demo in the beginning of the session since Omnity is in Asia, and over there it's pretty late in the evening, so we wanted to give them a few more minutes of time to go to sleep a bit earlier or less late. And after that, we have updates of metrics from Kyle, regular updates, and then Solenoid Milestone update from Boundary Node team presented by Rudiger. After that, we have Solana RPC Integration announcement from Gregory. And after that, we have two more demos coming from the NNS DApp team with the portfolio page presented by Andrew and Jenny. And after that, last but not least, OISY update or demo from Antonio. So Omnity, the stage is yours.
Okay, so RE tooling complete bridgeless execution layer for Bitcoin DeFi apparently built on ICP. RE stands for Runes Exchange Environment. It's an execution layer. We try to eliminate the awkward step of bridging, asset wrapping, or involve other wallets other than Bitcoin. From Bitcoin's perspective, RE transaction is an off-chain multi-party transaction coordination process happen on the other blockchain. So in our case, ICP. So PSBT and it facilitates a multi-party transaction for years in Bitcoin ecosystem, which means people can collectively sign PSBT and then the transaction can be settled on Bitcoin. This RE new paradigm is about move the signing process, the coordination process on ICP. And there will be two phases. The first phase is the trader negotiate deals with smart contract. Apparently, smart contract need to let's say control cryptographic keys, and so they can hold Bitcoin asset and join this PSBT signing process. And after the deal has been let's say agreed, the trader will form a PSBT to reflect all the terms of this deal, and they sign the input from himself, and then submit the PSBT to the coordinator smart contract. And the coordinator contract will call the involved smart contract one by one, ask them to sign, and if any of them refuse to sign, this transaction will fail. So the atomicity of the transaction will be ensured by the coordinator contract. And if all the involved smart contracts sign the PSBT, then it can be transformed into a settlement transaction and broadcasted to Bitcoin network. So apparently ICP, we call this, since the whole process happened on a public blockchain, the property of, let's say, permissionlessness and censorship efficiency will be guaranteed by this public blockchain. Apparently, ICP is the best public blockchain to host DPS, since chain key, Bitcoin native integration, on-chain indexer, reverse gas model, and the powerful platform itself. So the detailed step of of RE transaction is the first step would be user will use his front end to query exchanges, and essentially this inquiry means if I give you some BTC or some runes, what I will get in return, and if the trader satisfied with the term, it can a PSBT can be formed at the front end, and the trader will have to let's say sign the PSBT first, and then submit the PSBT to the orchestrator, which plays the role of the coordinator. And the orchestrator will query on-chain runes indexer and also Bitcoin canister to ensure that the input of the PSBT really contain the asset that it claimed to. And so the trader and exchange cannot cheat on each other. After the check, the orchestrator will ask the exchange sign the PSBT one by one, and if all good, it will broadcast the transaction to Bitcoin network. So this is the first exchange, the first DApp, RISwap built on RE. It's an AMM DEX, and I need to connect my wallet first. And from this address, I have a little bit BTC, but without any hope you'll get rich runes. And I can input BTC amount, and the front end will query the smart contract. It will return that I will get that much rich by paying that much Bitcoin. If I think this deal is fair enough, I will sign this transaction. So, and on the wallet address, it will appear that the PSBT which input coming from my wallet, which coming from the pool, from the exchange smart contract. After signing the smart contract, the coordinator will be called. Usually, it will take about 10 seconds to execute one transaction. So this transaction has been broadcasted to Bitcoin network. So there's two input. This one from my wallet, this one from the pool, and there are three outcome. So this one is the Bitcoin change. This one is the runes I about to receive, and this one is the new UTXO for the pool, which contain the change for runes and the BTC, and also it combine my my payment to this this UTXO. And the beauty of this environment is, even though this transaction hasn't been included into block, I can use the output of this transaction. I get that much runes. Hope you get rich runes from the previous transaction, and now I can add it to pool to become say an LP. Okay. So I need to sign this transaction. Okay, So it has been executed. So this one is the transaction for adding liquidity, and it's also broadcasted to mempool. And if the gas fee is adequate, most likely these two transactions will be included into a block. But maybe it will be included into two blocks. And so the second transaction is the children transaction of the first, since it used the output from the first transaction, and we use this CPFP feature to, let's say, to ensure that even if the parent transaction pay some lower gas fee, the children transaction can help to push the parent's transaction into block. So this will be the user experience of this swap, and it will be the first one. The launch date will be is scheduled on February 8, 10 days ahead of us. And after that, we will open the source code of this swap. And after the auditing and the risk swap, the RE orchestrator will be open source too. So RE is an open source, free to use, let's say, on-chain middleware for, let's say, ICP canister to facilitate Bitcoin DeFi. Okay, that's all from my side. Any questions?
Thank you, Lloyd. This looks really great. I do hope that you get rich too.
I hope so. And I hope all the early participants of RE can get their richness. Thank you.
We have next updates from Kyle. Kyle, the stage is yours.
I'll say I know the Omnity team pretty well, and I'll say keep an eye on them. Also, the Runes landscape is ripe for innovation and excitement, and so I think this is absolutely the right time to have an execution environment that makes the user experience great. So that's my 2 cents to add. Thanks for the presentation, Louis. My slides here, I'm going to focus the metrics on governance. That's been a topic of interest with the Plasma milestone that we've recently celebrated. And so I want to give some high-level looks into how the NNS is doing. For any new viewers, the NNS is the governance system for ICP. You can see that 44% of all ICP is locked in the governance system at this time. And of that, almost 61% is locked for 8 years, or which is really phenomenal in terms of the time horizon within the ICP community and how people approach governance. I'll say there's over 370,000 total neurons. Now, an individual can have multiple neurons, so that's not an exact total of unique entities, but you can get an order of magnitude of how many people are participating in governance on the ICP. And then finally, of course, one important thing is you have to have a lot of value protecting your governance system. And right now there's 2 billion in total staked. If we go to the next slide. One of the things I get asked a lot is an interest in terms of ICP that's dissolving off the NNS. So this is when, so this bar chart right here shows when ICP possibly could come off. So when neuron holders have decided that they want to get their ICP out of the system, there's a dissolve process. And this just shows you which month the earliest that they could possibly get it. The historical average for this has been about 3 million per month. So you can see there's a significant decline in the amount of ICP that's dissolving. And not only that, it's, once we get past January of 2026, there's very little ICP that can come off the NNS. I think what you're seeing is a lot of early neuron holders have the people who haven't wanted to participate in governance are getting out, and they're being replaced by people who are absolutely committed and looking at the long run. And so I will point out there's a note here about these are known IDs only. So these are IDs that the dashboard knows about. When we do neuron indexing, we'll be able to get all of them, but this represents about 80% of the ICP dissolving. You can actually calculate these numbers yourself using the dashboard's API. If we go to the next slide, just to present this information differently, this is the historical amount of ICP dissolving. That's that pink line. And then the yellow line is the percent of that of the total staked. And again, you see both of these just down and to the right, essentially participants who want to get out are dissolving their ICP, and they're being replaced by people who want to participate in the long run. At this point now, we have, it's about 14% of ICP staked is dissolving. So that means that 86% of the ICP staked is by people who have locked it for 6 months or longer. Again, really showing strong governance participation. That's my time. Thank you, Saša.
Thanks so much, Kyle. Rüdiger, it's yours.
Yes, thanks, Saša. And hi, everyone. So I'm Rüdiger, and I'm part of the Boundary Node team. And as the title says, I will tell you today more about the Solenoid Milestone. If you have been a regular here on the Global R&D, you have heard me talk multiple times before, providing you with updates, but I promise you this time it's different. And that's why I'm so excited about this. So today I can tell you that one of the last big missing pieces in decentralizing the IC is finally here, the decentralized edge infrastructure. But before we look into that, let's take a step back. What do I mean by decentralizing the IC? Next slide, please. So when we look at decentralization of the IC, like now at a very high level, it concerns multiple different aspects. First, it's the IC core, so where everything runs. It's governance, how the IC is controlled, so how upgrades to the protocol or topology changes are decided upon and enforced. And third, that's the one we want to talk about today, is the edge. Or put differently, how users can access the internet computer. So now core and governance have been decentralized from the beginning. We have IC nodes that are operated by more than 100 node providers. We have the network nervous system, a DAO that controls the IC. But the edge, however, that one has not been decentralized. Up until now, the boundary nodes, so the nodes that provide end users access to the IC, have been operated by the DFINITY Foundation, and they have not been under control of the NNS. Now, addressing this shortcoming, this has been the main goal of the Solenoid Milestone and the new edge architecture. Before we start looking at what is new, let's take a look at what the existing boundary nodes actually do. Next slide, please. So at a very high level, I like to compare the boundary nodes to mailmen. The boundary nodes, they take the user messages and they make sure that those messages are delivered to the right destination. In the sense of the boundary nodes, it's an IC API call or an HTTP request, and it will deliver it to the right subnet to a healthy replica. Now, in a bit more detail, this was the public interface of the internet computer until now. Every single request had to go through one of those boundary nodes. And as I already said, there were two request types. The first ones is the IC API calls, so a query, an update call. And all a boundary node did was take this API call from a client and route it to the right destination. The second type of the requests are HTTP requests. And for those, boundary nodes first would translate them into an API call and then handle them accordingly. To be more specific, if you, for example, opened internetcomputer.org in your browser, your HTTP request would reach a boundary node. That boundary node would translate it into an IC API call, send it to a replica. The replica would reply, and this response would be translated back into the HTTP response, such that your browser can display the website. So now you know exactly how it looked like before Solenoid, and we're ready to take a closer look at how it looks like now. So next slide, please. So I still kind of, for you as a memory, I kept the old architecture above, a bit grayed out, and below you see the new architecture. The main idea behind the new architecture is to split the, I call them legacy boundary nodes, into two components, the API boundary nodes and the HTTP gateways. And I stressed before so much these two different request types because the split actually happened more or less along these request types. So the API boundary nodes, they only handle IC API calls, and they now form the new public interface of the internet computer. You could call them the RPC endpoints of the IC. And just as the replica nodes, these API boundary nodes are operated by many different node providers, and they're fully under control of the NNS. So this means deciding which nodes are being added as API boundary nodes or removed or upgrades, everything has to go through an NNS proposal. The HTTP gateways, on the other hand, they mostly handle the HTTP requests, so this translation. And because of that translation, I look at them often as more an additional layer around the IC. So they connect Web 2 protocol, in their case now HTTP, to the IC by translating that. And after translating the HTTP request into an IC API call, the HTTP gateway simply forwards this to an API boundary node. Now, since those gateways run outside of the IC, anyone can set up their own gateway under their own domain name, and this could be just for their own dev, or it could be a catch-all gateway that could be used for the entire IC ecosystem. Now, one point that is very important for me to stress is that the HTTP gateway is just an example of one gateway. This new architecture with having the public interface allows to have many, many more gateways that connect some traditional Web 2 protocol to the IC. And here I'm thinking, for example, of the WebSocket gateway that the guys from Omnia Network developed, or maybe even in the future, some DNS or SMTP gateways. Now, from this overview, it might look quite simple. Just take the boundary node, split it in two, and we're done. Unfortunately, it was not exactly like that. And we also used this as an opportunity to completely redesign the internals of the boundary nodes, fix some issues, and just make improvements along the way. And that's what we want to look at on the next slide. So initially, the boundary nodes, they mainly consisted of Nginx. And then because Nginx is not really made to work with the IC, we had to add a lot of custom modules and services. And it was just one big patchwork. And as you can imagine, this patchwork is also not very performant. So we decided to completely scrap that and develop new services from scratch. In the end, we had IC Boundary, which is now the main service of the API boundary nodes, and IC Gateway, the service of the HTTP gateways. As it was quite an undertaking to develop these services completely new, we took a two-step approach. So we developed them and slowly integrated them in the legacy boundary nodes by just replacing Nginx and those modules with the new services. This allowed us to gather experience with those services and just see that everything runs smoothly. And I hope you actually didn't notice that we had this internal swap going on. And then now we had it for several months running in production. Everything went smoothly so far, and I hope it stays like this. And we were ready for the split, which happened just a few days ago. So yeah, looking back, it was a very good decision to create our own services, as we could really build exactly what the IC needed. And it also made our infrastructure more robust and performant. I talked now a lot about the architecture, how it looks internally, but I think you might more ask yourself, what does this mean for me? So let's go to the next slide, please. As the very first point, I want to say, in general, it doesn't have to mean anything for you. So everything continues to work as before. DFINITY continues operating the well-known domains. So this IC0.app, ICP0.io, ICP-API.io, and all the custom domains. And the only difference is that now DFINITY runs HTTP gateways instead of the legacy boundary nodes, and it forwards then the traffic to the API boundary nodes. So in short, for you as a user or developer, you don't have to change anything if you don't want to. But I think it can be very interesting and exciting to actually make use of the decentralized API boundary nodes. So we have at the moment 20 API boundary nodes under NNS control. They're operated by 18 different node providers and distributed all across the world. The DFINITY operated gateways, they already route their traffic through them. And yeah, they're ready to serve your traffic as well. Now, if you're a developer of IC native clients and you're using AgentRS, you're in luck. So AgentRS includes tooling to directly talk to the API boundary nodes. This includes the discovery, so finding out which API boundary nodes exist. It includes the health checking, and it includes different routing strategies. So you could do round-robin routing, or you can do smarter things like routing requests to healthy API boundary nodes that are close by to reduce latency. So that's already integrated in the agent, and we have also recorded a demo on how to use that. It should be released shortly, so just keep an eye on DFINITY's YouTube channel and watch it. Second, if you're eager to run your own HTTP gateway, I'm happy to tell you that the code is all open source. It's in the IC Gateway repository under the DFINITY organization. It includes instruction to run the gateway, and I also think it might be a good start if you have some HTTP Gateway++ in mind, so you can start from our code base and extend it in any way you want. And that's already it from my side. So I just encourage you, give it a try. Try the agent with the routing library, check the forum posts that are going out shortly, check the blog posts, and just let us know what you think. Let us know what your experience is. And yeah, before I hand it back to Saša, I just wanted to thank everyone involved. It was quite a big undertaking and an effort across multiple teams. So thank you very much.
Thank you, Rüdiger. I'm very happy that you and the boundary node team managed to bring this last piece of the IC stack into decentralized shape. Thank you so much. All right, features. Gregory, will you mind sharing what we have around Solana RPC integration?
Sure, thanks, Saša. So here's Gregory from the cross-chain team, and we wanted to give a quick announcement regarding an upcoming feature, which is the integration with Solana using an RPC canister. So what is this about? It's about allowing a canister on the ICP to be able to interact, so to read or send transaction to a program on Solana. And one reason why we wanted to do this announcement a bit early, because we didn't yet start implementing that canister, is because you're going to see soon a cool demo by Antonio where OISY already integrated with Solana. And there it's a different feature because they integrated with Solana by basically contacting Solana in the front end. And here we are talking about contacting or reaching out to Solana basically in the backend, so in a canister on ICP. So if you go to the next slide, so why Solana? Well, basically we want to go where the trading volume is. And if you see on this chart, so this is comparing like trading volume between Solana and Ethereum in the last couple of months, and Solana is in green. And what you can see basically is a trend where Solana is basically the king in terms of trading volume. So for example, a couple of days ago, it was at 9 billion. And in contrast, Ethereum was less than half than that. So if you go to the next slide, and that's going to be my last slide. So how do we plan on doing this? Well, basically, we want to extend the chain fusion capabilities of the IC. And we already have quite a few that I summarized here. So to be able to send transaction to Solana, we're going to need threshold Schnorr, which we already have. Solana can also verify natively ECDSA signatures, and this we already have with threshold ECDSA. We also, in terms of integration with other blockchains, we have basically two different stacks. We have the native integration with Bitcoin, or we have some kind of networking integration leveraging the HTTPS outcall feature of the IC. And there, that's what we use, for example, to reach any EVM chain using the so-called EVM RPC canister. And that's what we also plan to do with Solana. So to have a new canister that talks to the Solana RPC API. And if you click on the next slide, yeah, I just wanted to give you a little teaser. So you may think, well, that's just like the EVM RPC canister, right? A different JSON RPC interface, just change a couple of method name, rename a few struct, and that's it. And actually, there are like some Solana specific challenges because Solana is a very different blockchain than, for example, EVM chain. And one challenge there is related to the fast changing block height of Solana. So in Solana, if you want to, for example, get the latest block hash at commitment finalized, and if you were to do this little request, let's say locally on your shell in a for loop, then most likely than not, you will see different answers, which are different responses, which are given below. And that's because even at finalized height, the block height is going to change very rapidly, like in the order of 100 milliseconds. And so now if you think you get different responses locally, now you can imagine what would happen if you were to do this via an HTTPS out call, so which is a replicated call. So for example, 34 nodes doing the same call, then most likely than not, they will receive different answers and consensus will fail. So we'll have to come up with some inventive solution to work our way around that. And with this, back to you, Saša.
Thanks so much, Gregory. Very exciting. Let's see it done. Thank you. All right, demos. NNSD app.
All right, thank you, Saša. So hello, everyone. My name is Andrew, and I work on the NNS app as a product manager. Can I ask for the next slide, please? If you haven't signed into the NNS app this week, or if you have signed into the NNS app this week, you should have seen a new exciting homepage called the Portfolio Page. And if you haven't yet, let me show you today. I want to quickly say that if you're not familiar with the NNS, it's the on-chain governance system that controls and governs the Internet Computer Protocol. And the NNS dApp is this front end that allows users to interact with the NNS through this simple user interface. And you can go to it by going to nns.ic0.app. And since this week, as the proposal was adopted on Monday, you should see this new beautiful homepage, which is kind of a continuation of one of the features that was highly requested by the community, which is to add fiat values to the NNS. So on the homepage, you will see your total holdings. This is a test account. I wish I had this. And on the left, you see your total token balance, which is the tokens that you hold, and you can easily reach the tokens by clicking this button, and it shows you the top 4 tokens that you hold. And on the right side, this is a summary of your neuron staking balance, or all the different projects that is ICP or the NNS neurons that you hold, and then all the SNS neurons that you have below. So this is how it looks currently, and in the future, we plan to extend this and make it even more useful and add new features we propose to add new features that show different parts or different exciting new news in other parts of the NNS app that will help users start taking action already. And to say what's coming in the future, I would like to pass it on to Jenny.
Wonderful. Thank you, Andrew. So we'll move on to the next. And here's a little look into the future, what's to come. So pretty exciting. So as of today, when you're logging in, you can see your total holdings, the main tokens that you're holding, the main staking that you have as well. And when you operate, especially for the newer users, you have a bit of a guidance in how to get started. Now, what's additional will also be highlighting our new projects as in our launches on the launch pad. So we will have our upcoming launches, the ongoing launches, and then also eventually the NNS proposal to create SNSs. So we're starting to connect further on. So very exciting, and yeah, stay tuned for the future to come.
This looks great. This is gonna greatly help people manage their various tokens that they hold. Thank you. All right. The last demo for tonight, OISY.
Yes, I'm Antonio from the OISY team, and can I have the next slide? Today I'm going to present two features that are very dear to us. One is Solana, and the other one are the embedded swap for ICRC. So right now, as you can see, obviously we have first the Solana token plus a bunch of other Solana tokens that we want or not to turn on and off. We can even decide to have specific custom tokens that we maybe want to add as user because we don't have in our list, but we like it a lot and we have balance there. And like we do in general for ERC20. So we actually replicated the structure that we were doing for Ethereum and we replicated in Solana. One of the first non-trivial things about Solana, I don't know if everybody's aware of it, is that for each new token, you have to have a sub-address of your main address that can hold the tokens per se. So different from Ethereum, for your main wallet address of Solana, you have sub-addresses for each of the token that you want to hold on. So one of the things that was we had to code in is that when we want to transfer a Solana token to a wallet that doesn't have this address already, we need to open it. And this is not as easy as the other transaction because basically Solana is a bunch of smaller instructions or transaction all bundled together and send them out with our single signature. So for example, we want to send to a wallet that doesn't have, for example, a Trump, one random token, a Trump sub-account. We need to first create this account and then send the tokens to such a wallet. We can see it shortly because right now we rely on, as Gregory introduced before, we rely on a third-party RPC for now, awaiting the IC Solana RPC coming soon, right? And so for now we are still relying on a third party. So the integration was basically the signing part done via the signing canister and the whole interface with the RPC Solana method. It's taking more than usual, probably because it's a bit busy on the network. We are awaiting the confirmation. I hope it will be soon enough because I want to proceed with the... But in the meanwhile, I will share something else with you. I will show that we can even connect with the Wallet Connect for the Solana networks. 1 second. I will grab one link here. So we include, so yes, we sent it. It was successful. We saw it. And now we have 0 tokens here. And what I wanted to show is that we created for the new one a new sub account for the token that we sent. Now we can see, for example, for Wallet Connect, we can, as always, connect to generic Wallet Connect DEX. We can swap and receive approval or not approval. We can reject it or not. There are still a few things to tune up, like for example, parsing the transaction, because each DEX provides a different program with different series of transactions that needs to parse correctly. But for now, we are again providing a signature and something went wrong, probably the slippage, and the DEX will take care of the transaction per se. We just signed the transaction. The second feature that we wanted to show is that we finally included the swap with the Kong swap for now, but with more providers will come soon. An internal swap service. This was the work done by Dennis. He was the lead on this feature, and let's try, for example, a small swap like ICP versus CKUSDC. A few features that were not easy codable, because, for example, the most important part is the slippage, right? We need to be aware of how much the provider accept or not accept the slippage, for example, and we put a limit of 50% that is too much, or even warning about a high slippage. But a basic slippage or common slippage is okay. For the rest, we provide the option to set it in dollars, more fiat to come soon. For example, instead of one ICP, I want to set it as around $10, and then we swap it. And more details about obviously the fees on the provider per se. What is coming more with that is, again, as I said, more providers on that. A way to soon enough have more tokens to be swappable. So again, this will depend on providers too. But yeah, that's it for the swap feature. In general, both these features were a huge work. There was a huge amount of work behind from the entire team. I know that it seems kind of a given that we have these kind of features at some point, but this was again amazing works done by everybody, all the developers in the teams, the project owners, the product manager, sorry, and yeah, we continue to provide more and more features to try and show that OISY can be really the cross-chain wallet for excellence. And that's it on my side.
Thank you, Antonio. This is great. I'm looking forward to using it in real life.
Please do. Please do.
Thank you. So thanks everyone for watching. This was all that we had prepared for tonight. Please join us for the next Global R&D session. Have a great day and great evening. Bye.